All right, hey gang. I really hope that you have a great time outside today. Wanted to go over a couple of things with you real quick as far as the area of a circle. I know that's mostly review, but there's some more specifics when we get into geometry, just being a little bit higher level math. So let's get right into this and take a look at a couple of problems. First of all, in number one, we are talking about, let me make this, let's see, that's better. There you go. We're talking about the area, and we want to round to the nearest tenths place. So in number one, if I want to find the area of this circle, the area formula, and you guys have known this for a long time, is pi r squared. I think I've shared with you guys that how I remember that is because when you have an area, you have square units, so radius squared makes sense, right? Pi r squared. So when I plug in my value of the radius length, okay, so the radius is 5 over here. This one will be just 10, not 20, just 10 is the radius. I end up having this 25 pi square inches. Now that is the most precise answer I can give when talking about the area of that circle. I have not rounded in any way. But if you go ahead and plug that into your calculator, which I do not have with me, and I'm back. 78.5 is what we're looking at for the area. 78.5 square inches. So almost 79 square inches cover that circle right there. Okay? So, yeah, area of a circle, pi r squared. Now, as we look down numbers 4 and 5, we have to get a little bit more creative, okay? A little more in depth. How are we going to find the area of this shaded region right here, this outer ring, okay? Well, I guess I'm hoping what you are thinking is if we take the area of the big circle, and subtract out the area of the small circle, what's left over is going to be the area of the shaded region, okay? So, if I think about this, what is the radius length of the big circle? Well, we know the diameter right here is a total of 9 centimeters, and so the radius length starts from here and goes to here. That's half of the diameter. So I'm going to say 4.5 centimeters is the radius of the big circle. And the radius of the small circle, if we know that these two are congruent, I can take my 4.5 and divide that by 2. So a 2.25 would be the radius of the small circle. And the difference would be the area of the shaded. So it's really that simple. Find the radius of the big circle, find the radius of the small circle, take the difference. So if I do that, pi times radius squared minus pi times radius squared. Oop, not squared. There we go. Okay. So it looks like 47.7 square inches is going to be your area. Not inches, sorry, centimeters of that shaded region. Okay? All right. Oop, we're getting a little off track here. There you go. Okay? Now, for this other one, I showed this to some kids earlier today, and their minds were kind of blown. Like, how do I manipulate? That's the key word, manipulate. Change the shape so it's an easier shape to figure out the area of. Well, here's what I'm thinking. What I know right now is the radius of each of these smaller circles right here, they're all the same. Markings right there. So if the radii are all the same, what do we know about the circles in general? Well, they're the same as well. And so this is a half circle here, a half circle here, and this is a half circle here. They're all congruent to each other. So I guess what I'm thinking is if I take this half circle right here and rotate it around this point 180 degrees, it will become this half circle right here. Okay? And so with that understanding, I guess what I'm thinking is let's take the area of this half circle and subtract out the area of this half circle. And what's left over will be this shaded region over here. Okay? So I'm going to take the area of the big half circle, pi, again, 6 squared. Okay? The diameter was 12, so the radius is 6, minus 1/2 pi. Now let's see here. If each radius is the same, which it should be if it's a true circle, then that means that we have 1, 2, 3, 4, 5, 6 different radii there. So if I take the total diameter and divide by 6, that gives me 1 radius length. And I'm going to plug that in right there. Okay. So this will be the area, this right here, again, is the area of this portion right here. And this right here is the area of this whole portion right there. Okay. So if we work on that, 6 squared, right? Okay. We're looking at approximately 50.3 square inches inside that shaded region. Okay, so I like these type of problems where they challenge you and force you to, how can I manipulate this? How can I move this in a way that will allow me to see the answer or get to the answer? All right, I've got 2 more problems I wanted to go over with you, and then I will let you go here. The next one talks about this: find the indicated measure, round to the nearest tenth. The area of a circle is this, find the diameter. Okay, now if I mark this out, area is pi r squared, and I write in that 153.9 is my area. Okay, how do I find my radius length? Okay, well, if I divide both sides by pi, that will give me the radius length. Now I know that just human nature, you guys are going to want to reach for your calculators right now. Don't do that, okay? I want to keep everything a part of my answer to the very end, and I don't want to round at any point until that point, till the very end. Now the question is, how do I get the radius by itself? Well, I hope what you're thinking is you're going to square root both sides. So if I square root the left side and square root the right side, that's what we get, okay? Now, remember, the diameter is twice the radius. So if I double this, that's my diameter, okay? So it does say nearest tenths place, so I'll go ahead and type that in. 2 square root 153.9 divided by pi, 13.998. Nearest tenths place would be 14 centimeters is my diameter. Okay, approximately 14 centimeters. Ooh, sorry, I thought that was up there high enough. There's my calculations there. Okay. All right, now for the last problem, we're going to go ahead and take a look at this one right here. The circumference of a circle is 907.9. Find the area. So I'm going to talk about circumference. Now we can use pi d, so circumference could be pi d, or 2 pi r. Since the area formula requires us to use the radius, pi r squared, I'm going to use 2 pi r. Okay, so if I plug the 907.9 in and solve for the radius length, if I go ahead and divide by 2 pi, I think what I'll do at this point is take 907.9 and divide by 2. So this ends up being 453.95 over pi. Okay, 453.95. Now, if I plug that in over here, square that, and then multiply it by the pi, I can approximately figure out what the overall area is going to be. So pi 453.9 divided by pi squared. Let's see here. Yep. So big number there, but remember the circumference was a big number as well. So 65,579.9, and I'll go square inches. Okay. So I guess my hope here, guys, is to show you this. It's good work. This is showing everything that happens, and I never needed my calculator to the very end. We don't want to have to rely on that technology there. And so that's how I'd like to see it worked out. Okay. All right, now to finish things off, here's what I'd like you guys to go ahead and do. First of all, you're going to finish up this first page front and back, okay? So get both those sides completed for me. And then I'd also like you to do this, and I'll write this down here, okay? In Schoology, I think it said page 745. Let's see here, 745, and I think it was numbers 7 and 33 to 35. Okay. You might want to double check that in Schoology, but I believe that's what it was. 745, numbers 7 and 33 to 35. Okay. I am going to post these answers on Schoology as well. So double check my answers here, make sure that you did them correctly, and we'll talk about anything you have questions on Monday. So, hey, have a great weekend, folks. I'll see you on Monday.